Alrighty, so welcome back, everyone. Today we are going to be going over how you can actually import your data from an existing data set. Um, you're not going to be making up your own data like I did with the housing prices. Instead, you'll be locating your data sets out in the wild, cleaning it up a little bit, and then importing it so that your code can actually train the model and get some hopefully nice results for you. So let's go over that today. I think that would be very, very, very helpful. So I'm going to start with showing you a data set that I got from, where did I get this data set from? This one was from, this was Kaggle. Yeah, if you don't know, Kaggle, Kaggle, Kaggle.com is a wonderful place for machine learning. Um, Data sets, all sorts of really nice articles on the most efficient way to do things. And there are some competitions. There's big money available if you can win some of these competitions. Companies put large cash prizes up for the person that can or team that can come up with the best solutions. So, anywho, so this is the data right here. Um, this is taking a lot of features from cars and seeing if you can predict the price of a car based on those features. Um, so the very first column in this data, this car ID, is not going to be used. Um, it's there for reference, but you don't need to know the ID of the car when you're actually training your model. Uh, but the other ones are things like the insurance risk, um, which is it rates how much insurance a car would need based on the risk associated with it, and then uh, sees if that actually helps you determine the price. And it sort of makes sense. If a car is a large insurance risk, probably that's due to it being an expensive car that can go very fast, things like that. So it probably has some bearing. The next one is whether it's a gasoline engine or a diesel, uh, turbo, the number of doors, car body type, sedan, all that. Um, the type of drive it is, four wheel, two wheel, front wheel, all that stuff. And then some basic measurements and so forth and so on. And finally, the price is listed at the very end of the data set. So how many, let's see how many elements there are to this. I don't know if it will work. It's not a ton. Uh, Looks like it's 206 individual training examples. So not a ton, but that's reasonable. You should be able to probably get a decent R squared with a fit line to that data. So did the data disappear when I scroll down? Weird. Um, Anyways, so that's what the data looks like. I did a little bit of cleaning up, changed some of the original data set from words to actually numerical data because that's what our linear regression, multivariate linear regression kind of requires is have numeric values. So um, that was about all I did. I had to clean up a few other things, but it was a pretty clean set. So now that we know what the data set looks like, let's actually look at the code that we're going to be using for this. So let's see, trying to figure out how to get there. Yeah, take that and hopefully, hey, there we go. It worked. Okay. So reading in from a data set is a little bit different than coming up with the data on your own. What you want to do is typically you're going to open it up with Pandas because, as we talked about with the last video, Pandas is really good at reading data that is a mixture of numeric and non-numeric data. It's what I go to as default, pretty much. It's fast, very easy to actually manipulate the data with the data structures inside of it. So I'm a huge fan of pandas. So what we're going to be using is this right here. Let me scroll over to this right here, this pd.read underscore CSV. So what we did up here is we imported pandas and we kind of renamed it as PD. That's standard for machine learning. You'd never see someone type out the full name pandas. They import pandas as PD, and then whenever they type out PD, it's the same thing as if they had typed out the full word pandas. It just lets you kind of do a shortcut, makes the code a lot more readable. So the read underscore CSV within pandas lets you import your data from a CSV file. It's extremely robust. It handles things that I'm surprised it doesn't error on sometimes. It can handle some really messy data files and still be just fine. I don't recommend that. I recommend you clean your data before you import, but we'll talk about that more as time goes on. So what we have here is this PD, which is the pandas, .read underscore CSV. All you have to do is feed it the file name of the data set that you're trying to import. It needs to be in a CSV format because that's what read CSV is looking for. Oh, and I keep saying CSV. What does CSV stand for? Comma separated values. So your data is every single one of the cells in your data is separated from other cells by a comma. So that's what CSV stands for. And even though when I was looking at showing you the spreadsheet, it looked like it was columns, very neatly organized Excel columns. But the reality is it's just a text file with every single data cell separated from the others with commas. It's very hard to read a CSV, which is why I highly recommend importing it into Excel or something similar to actually get an idea what the data looks like. So notice we are not using the data frame because the read CSV is reading from a spreadsheet. So it doesn't need to kind of make its own spreadsheet with the data frame. It's already reading it from a spreadsheet. So, but it handles it exactly the same way. If you look right here in the code, we are reading the CSV and storing that spreadsheet in text. Then it is handled identically to, if you make your own data up like we did with the data frame. All you have to do is feed to your X variable your set of features where you are going to send the headers of each of the columns as the arguments. So each one of these is a header inside the Excel sheet that you saw. Insurance risk, gasoline turbo, number of doors, etc. And so all of those features get sent to X. The price, which is the very last column, which you couldn't see because it's over a little bit, is fed into the Y variable. So now all we do is exactly what we did before. We store the linear model in Regra. Then we do the fit, and then we just peel off the coefficients. And at the very end, we're going to look at the R squared value. So if I run this, and note one other thing that is important, there is no like directory structure in front of carprice.csv. That means it's going to look for it in the same directory that the code resides. If you don't specify a directory path, it automatically assumes that the file is in the directory the code resides in. So when you're actually running these, make sure that you have your CSV in the exact same directory. It will save you a lot of trouble. And if you're using a Mac, I'll cross my fingers for you, but Mac tends to have problems with um, paths. If you do have trouble, send me an email. Um, we'll get it figured out. I have never had a semester where people that use Macs were able to import data without any kind of workaround. So we're going to cross our fingers. But anywho, if I run this now, this is what we get. Insurance risk is a factor in the price. And these are in actual amounts, so dollars. I think maybe a different currency. I don't remember if it's dollars or not, but um, it looks like the insurance risk had some effect. It was worth $344 in the price per insurance risk, which makes sense. A more risky uh, automobile would probably be one that would cost a little bit more. Um, then we have gasoline type. It is very influential whether or not you have a diesel or gasoline image. But that makes perfect sense. It's a very large component of the car. If you have a normal engine versus a diesel, it's going to have a large impact on the price. Um, Everything else is fairly sedate. The type of drive um, is kind of interesting. It actually has a pretty big effect on things. But as we look through, nothing else had the same impact as whether it was a diesel or a gasoline image. We did get a pretty big impact on the width of the car. I am at an absolute loss to figure out why that would make a big difference. I also noticed that the height and the weight also have an effect, but the length has a negative value. I'm guessing if you picture a car that's very wide and not too long, it corners well, so it's got a good center of gravity. So maybe it's a sportier car. I'm not sure why that is such a large value, but for our very rough analysis, that's the way you can kind of start thinking about these things. When you get your parameters, your thetas, when you solve for all of those, it gives you an idea of how much each of your features is affecting your outcome. In this case, the price. So the R squared was 0.85. That's not a bad fit. It's not the best fit. It's a decent fit. So we know that it's probably it's better than chance, but it's not as high as I would like to see it. I generally don't like R squared values under 90, if 0.9, if I can uh, get away with it, if I can arrange things to where uh, the data is nice and clean, etc. But sometimes you just get what you get. The R squared in this case, 0.85, I'll take it. No worries. So that's it. The only thing that changed from what we talked about in the last lecture was instead of having the data inside the code itself and assigning it into a data frame, now we're just going to read an actual CSV and then import all the column headers, fit the model, and then kind of unpeel the coefficients to see what was having the most effect. And that's it. That's all you have to do. Um, so I hope this made sense. Hope it wasn't uh, too odd, because what I'd like for y'all to do is I'm going to put this up on D2L, and then I'm going to put another data set, a CSV, up there. What I'd like for you to do is to replicate what you did with this one and make your own code and import the other data set, which is going to be, can you predict temperature based of a location based on um, some of the weather characteristics of the location. Um, Turns out you can. You absolutely can. So, yeah, I will put all this up on D2L, and I'll send out an email kind of outlining what I'd like y'all to do. And that is pretty much it. A nice, short, sweet lecture. I know you're itching to get in there, type it up, and import your very first CSV to see how it fits. So enjoy, and I will see you later. Bye, everyone.